Okay, let's take a look at some absolute value equations here. First thing we're going to notice here is that the quantity 2x plus 1 is within the absolute value sign, so therefore we're going to try to isolate that. We treat it almost like we would treat parentheses in an algebraic equation, but they're not the same as parentheses, but we want to treat them similar for this purpose. If this is minus 3 times whatever's in the absolute value sign, we want to actually divide by minus 3 to get rid of it. So when we divide both sides by minus 3, I'm going to be left with this, and I get a minus 9 over a minus 3, which minus divided by minus gives me a plus, 9 divided by 3 gives me a 3. So now I have a new equation. Notice I haven't even bothered to, write in there what's inside the absolute value because I don't care at this time. However, I do know it's 2x plus 1, and now I've isolated this, just like you should isolate parentheses in solving an algebraic equation. Now here's why I did that, because there's two situations that'll make this equation true. First of all, if 2x plus 1 is a positive number, the absolute value signs here don't really matter. Positive number is already positive. You just take that value, and if that is equal to 3, then that's going to be a true equation. The other situation, though, is a little more interesting. If 2x plus 1 turns out to be negative, then the absolute value of a negative just switches it to a positive. Therefore, if 2x plus 1 equals minus 3, keep in mind that minus 3 absolute value would give you positive 3. It still makes it a true statement. So I've written two scenarios here. Once I isolate what's inside the absolute value sign, I write two solutions. 2x plus 1 equals 3, the positive part of this equation, or 2x plus 1 equals minus 3. I simply add a minus sign in front of the right side of the equation, over here the 3, and I have to solve both. Okay, so now 2x, if I subtract 1 from each side, 3 minus 1 will give me 2, or the solution x equals 1. 2 divided by 2 gives me 1. So there's one solution. 2x plus 1 here. When I subtract the 1 in this equation, minus 3 minus 1 gives me a minus 4. Divide by the 2 here, so I get x equals minus 4 divided by 2, or a minus 2. I have two solutions now to the same equation. So don't take my word for it. Let's test it. All right, remember this equation up here. Minus 3 times absolute value of 2x plus 1, okay, gives me a minus 9, they say. Okay, double check. Okay, that's what we got. Okay, let's test these solutions here. That's a minus 9 there. Okay, so let's test our two solutions here. If I plug in a 1, 2 times 1 is 2, 2 plus 1 is 3. Minus 3 times absolute value of 3 certainly does equal minus 9. That's minus 3 times 3. It works. So this solution works. Try this one over here. Okay, 2 times minus 2, if I just plug it in for x here. Okay, 2 times minus 2 is a minus 4 plus 1, but I take the absolute value of that. That's a minus 4 plus 1, which is a minus 3. Absolute value of minus 3 is 3. So now I had the minus 3 out front. This is now the absolute value of minus 3, and that certainly is minus 9, which is the right side of the equation. It makes it true. Therefore, we've proved that this answer works and this answer works. There's two answers. Now, some books like to write your answers set up like this, 1 and minus 2, and that's fine. You know there's two solutions, x equals 1 and x equals minus 2. They both work. So absolute value equations are going to have two answers like this. That's how you do those.